We are live. Hi everyone, welcome back to Code Era. Today in this video we'll be solving the LeetCode daily challenge for 9th of Feb. The name of the problem is K different pairs in an array. Previously this problem has been asked in Amazon, Microsoft, Google, and it's also been asked in Facebook. Right, so consider giving me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible. And then within a couple of minutes I'll start with this problem, right? You can just consider to give me a +1 in the chat if my voice is audible, screen is clearly visible, so that we can start with this problem as early as possible. And this problem is a pretty good problem because it has been asked in several organizations, right? So you can just give me a +1 in the chat if my voice is clearly audible to all of you, and we'll start with this problem. Right. So this problem has been, as I said, this problem has been previously asked in organizations like Amazon. It has also been asked in Microsoft, and it has been asked in Google and Meta, that is Facebook. So these are the top companies that have asked it. Although Twitter has also asked this problem, Twitter and Oracle has also asked this problem, but more frequently Amazon, Microsoft, Google and Meta have asked this problem, right? So let's start with this problem. Now in this problem what you have to do is, in this problem you will be given an array nums, right? You can just give me a +1 in the chat for a little bit of acknowledgement that everything is working fine. Now in this particular problem you will be given an array, and what you have to do is you'll be given an array and you'll be given an integer k, and you have to find all the unique k different pairs in the array, right? In this particular array you have to find all the different unique k different pairs, right? So you'll be given an array nums. You'll be given an array nums. Let's say that if you have been given the sample example, so 3 1 4 1 and 5, right? If you have been given 3, then 1, then 4, then 1 and then 5, if you have been given this particular array and you have been given k value as nothing but 2, if you have been given k value as 2, so what you have to do is you have to check, you have to find you have to find all the count of unique k different pairs in the array. What is a k different pair? A k different pair is such that you choose two elements, one at an index I, another at an index j, such that this will be a very interesting discussion, please believe me. So stay till the end, right? Now what you have to do is, k different pairs means what? That you have to find an index I and an index j such that I and j index are not the same. So you have to find two indexes such that nums of I and nums of j, right? If you subtract these two elements, take the modulo, so the absolute difference of nums of I and nums of j should be equal to k. If this is true, then it will be said as a k different pair, right? And you have to count all such pairs. Like in this particular example, if you will find all the k different unique pairs, so one element if you take 3, another element if you take 1, so 3 minus 1 would give me what? 3 minus 1 would give me 2, and this is the value of k, right? So it's equal to k, right? So that's why this will be one of the pairs. Like another thing that you could have done is like 1 minus 3 mod, this could also have been 2, so that is the same, right? That is the same. You just have to take the absolute value, that is the positive value, right? Another thing that you could have done is, instead of choosing 3 and 1, you could have chosen, let's say 5 and 3. If you chose 5 and 3, then 5 minus 3 mod, taking the mod, would be equal to nothing but 2, that is equal to k. Also mod of 3 minus 5, if you take it other way around as well, so 3 minus 5 mod would give me 2 as well, so this would be k. This is also k. So there are two pairs, right? There are two pairs such that I can do this, right? If this is 1 comma 3 and 3 comma 1, so I'll count it as one single pair, right? That's why I have to take the absolute value. Please give me a +1 in the chat if this question part is clear to everyone, and then I can move to the solution part, or the approach, like how we can approach this particular problem, right? For a particular value, you have to find, for a particular value k, right, you have to find total k different pairs in the array. That is, you have to find two elements such that their absolute difference is equal to k, and you have to find all such pairs, right? Is it clear to you, Samadhan and Shreya? Please give me a +1 in the chat if this much part is clear to everybody, and then I'll be moving on further with this question, right? So I hope that this much part is clear, right? That's what you have to do. Now let me take another example. If the test case is a little maybe tricky, let's check the second test case. So if the second test case is like 1 2 3 4 5 and k value is 1, right? Let's say that second test case. So second test case is nothing but 1 2 3 4 and 5, and the value of k that has been given to me is 1, right? So I have to find count of all the k different pairs, right? So can I say that if I have the element, if I have k is equal to 1, then I need the difference of nums of I such that nums of I and nums of j, I and j are not at the pointing at the same index, so nums of I minus nums of j mod should be equal to k. Can I do it like this? 2 minus 1 mod would give me 1, then 3 minus 2 mod will give me 1, then 4 minus 3 mod would give me 1, then 5 minus 4 mod would also give me 1. So total there are 4 such unique pairs, right? Now you will not say that 1 minus 2 also gives me 1, because it has been said that you have to find all different unique pairs, right? So if you will say that you can take maybe and nums of I as this, nums of j as this, or nums of j as this, nums of I and this, this will not be considered, right? 1 comma 2 will be considered as one pair, and 2 comma 2, both of them will be considered as same pair, right? I hope that this much part is also clear. Now let's understand the problem a little bit more better, right? Let's say whatever the data has been given to us, let's say the data given to us, that is 3 1 4 1 and 5, right? Let's say the data is 3 1 4 1 and 5. Let me make some spaces. 3 1 4 1 and 5. Now I'll be telling you both the approaches to solve this problem. Just stay patient with me, right? Now this is the array that's been given to me. The value of k that's been given to me is nothing but 2, right? What the intuition that I can get is, that maybe I can run a brute force order of n square approach, right? Maybe I can run an order of n square approach and then check that whatever is the number of pairs, unique pairs, as that a of I minus a of j, like a of j minus a of I modulus, like taking is equal to k, and I can do this, right? Order of n square or something like this. But this will be very bad to do, right? This is very brute force. This is something that I should not think of, right? This is something that comes to my mind instantly, but I will do it in a smarter way. What I can do is, can I say that if the smaller number is nums of I, let's say if the smaller number is nums of I, can I say that the larger number, that is the number which will we have, that can I say if nums of I minus nums of j, if this is k, can I say that if the smaller number is nums of I, can I say that nums of j would be nothing but, can I say that the other number in terms of I, that is nums of j, would be nothing but k plus nums of I? So that means that whatever the current element I have, I add k to it and I'll get the its pair, right? If I have nums of I, if I have a particular number, if I have a particular element nums of I, and if I have k plus nums of I, so that will mean that the pair would exist, right? That will mean if I have the element nums of I, so the other element should be k plus nums of I, then the difference would be k, right? And I am assuming that nums of I is a smaller element, so the larger element should be k plus nums of I, only then the difference would be k, right? What I'm saying is that you have k plus nums of I, right? You have k plus nums of I. If you have k plus nums of I present in your array, can I say that this pair will exist? Yes, I can say that, right? So what I'm saying is you can do what? You can do the sorting approach. What you can do in sorting, I'll tell you, just give me a second, right? What I'm saying is, you can first of all think of sorting. So you sort it 1 1, then 3 4 and 5, right? So this is the sorted array, right? This is in terms of sorted. Now what I'm saying is, assume up till now, if things are clear, so you can write yes or clear in the chat, right? What I'm saying is, you have this particular element, right? If you have this particular element, if the nums of I is 1, if the element is 1 and the k value is 2, so the other element should be what? Other element should be 1 plus 2, 1 plus k, right? If the first element is 1, if one of the elements is 1, then like if I want the difference, if the first element is 1, then the second element should be 1 plus k, right? You will agree with me on this part, right? If the first element is 1, so the other element should be 1 plus k, only then their difference would be k, right? The larger element should be 1 plus k. Now what is k? K is 2. So 1 plus 2 is what? 3. 1 plus 2 is nothing but 3. So if I have 3 in the array, in the right part of the array, from this index up till this index, if I have k, then if I have this particular element, right, that is nums plus k, nums of I plus k, in that case I'll do a count plus plus, right, I'll do a count plus plus, right. Is this part understandable to all of you? Now if I have this element, right, if I have the current number is 1 and I'm searching for 1 plus k, right, I want to look whether 1 plus k exists or not. So 1 plus k is nothing but 1 plus 2, so that is nothing but 3. If I want to search for 3 in the rightmost part, so if I am currently at this index, so I want to search from here till here, I want to search for the element 3, right. Shreya and others, is this clear to you? If it's clear, you can consider to like this video, right. What I'm saying is, if you have the element 3 and you want to find the element 3, can I say that in this search space, that is from I plus 1 up till n, I can apply a binary search because the array I've sorted the array, so I can apply a binary search. Can I say this, right? I can apply a binary search and check if the element is existing or not. If the element is existing, then I'll count it, otherwise I'll not count it, right? Is this much part clear to you? I have the current element as 1. The element that I want is, to get a difference of k, the element that I want is 1 plus k, that is 3. So in the search space, that is from I plus 1 up till n, that is the end of the array, I'll be searching whether this element exists or not. Either I can search it through linear search, but it would take order of n time. I can apply a binary search on this and it would take n log n time, right? Not n log n, but it's basically log n time, right? For one query it would take log n time, so that's why it will be optimal, right? Now you will say that okay, this is understandable. Now you will say that okay, this seems to be understandable, but there is one problem with the approach that I am telling. What is the problem with the approach that I am telling? I am saying that for when you are at this element, so you search in this space, in which element you will search. If the current element is 1, so the element that you want is 1 plus k, that is nothing but 1 plus 2, that is 3. So you'll get 3. So you'll say that okay, one pair could be 1 plus 3, so I'll count it, right? Now you will say that okay, what if my I moves, what if I move to the next element? So now you will ask me that if I move to this element, then I'm searching in this and this space, so the element is 1, so that's the element that I should be searching for is 1 plus k, so that is I would be searching for 1 plus 2, that is 3. So I will search for 3 again, I'll get it, so maybe I'll count 1 plus 1 comma 3 again, right? Is this the doubt that occurs in your mind? This doubt would be occurring in your mind, right? But to avoid this thing, to avoid this particular circumstance where I'm counting a particular pair twice and I'm not able to count all the unique pairs, I can use the set. I can insert all these values into a set. If I'll insert all these values in a set, so they will occur only one time, right? They will occur only one time. So that is what is going to happen, right? That is what is going to happen. If I am inserting them into a set, then in that case 1 comma 3 will occur only once, right? After this I'll be at this element. So if the current element is 3, so I'll want what? 3 plus k, so that is nothing but 3 plus 2, that is 5. If I want 5, so I'll search in this space, I'll use a binary search. So binary search will take a log n time to search, right? One binary search takes log n time. So that's why what will happen with this 3, I'll get the pair 5, so I'll insert 3 comma 5 here, right? So if I'm using a set, so I'm assured that I'll be always having the unique pairs, and to insert in a set it takes log n time, right? So it will also not take much time, right? Now what will happen? Now I'll be at this element 4. So for this element 4, I will need a 6, but I'll not have it, and for the element 5, I will not have any pair. So that's why total number of pairs that I'll have here, unique pairs which is having k difference, is nothing but 2. Here the total number of pairs is 2. That is, first is 1 and 3 and second is 3 and 5, right? These are the 2 pairs that I have, right? I hope that this part is clear. Now what I was doing in this question, first of all I was sorting the array. So for sorting I am taking n log n time, right? For sorting, then I am doing what? Then I am iterating through every element. For one element, I am iterating through every element one by one, like this. I am iterating my I one by one through every element. So what I am saying is, suppose that I am at this particular index, right? If I am at one particular element, then what is happening? I am searching in the rest of the space and I am doing a binary search. So that is taking log n time, right? That is taking log n time. A binary search takes log n time. So for one element, if I am taking log n time, so that means for all the elements, if I am doing the binary search, like if I am doing the binary search for this element, then this element, then this element, one by one for every element, so it will take n log n time, right? That's the overall that it will take. So I'll say okay, let's take this much time as well. So I'll say okay, we will take this much time. So that means order of n log n time for the searching part as well, searching and finding. And every time I am inserting the pairs, so this takes log of n time in the set. And if suppose that in the worst case there are n different pairs or n minus 1 different pairs, in that case it would be order of n log n. So overall time complexity of this particular approach using the binary search and the set concept would be order of n log n. Please write clear in the chat if this part is clear to everyone. Please give me a clear in the chat if this part is clear to everyone, and then we'll proceed further to the other part, right? Is this much part clear to everybody? Is it clear to everyone? Is it clear? I hope that this part is clear to everybody, right? So what I'm doing is I'm first of all sorting the array. Then if I have an element nums of I, assuming nums of I is the small element, then I will need to find nums of I plus k. If I find it in the right part, that is from the index I plus 1 till n, in that case I'm applying a binary search. If I find it, then well and good, and I'll insert into the set. Why am I using a set? Because I want to find all the distinct pairs, right? This is what I'm doing. Let me show you the code part for that particular approach. Also, I have provided the Java as well as the C++ code in the description of this video for both the approaches, right? What I'm doing is I'll show you what I'm doing. It's very simple. I'm doing what I'm using a first of all I'm sorting the given nums array, right? Then what I'm doing next is I'm having a set of pairs, right? Set of pairs. Why set of pairs? Because I'll be storing nums of I and nums of j, right? So that is I'll be storing in the set, I'll be storing nums of I comma nums of I plus k. That is nums of j would be what? Nums of I plus k, right? If I want to have a difference, that is why I've sorted in ascending order. So this is what will be stored. I have the int num, n is equal to nums dot size, so I'll have the size. Then I'll iterate for each element, right? I'll check for each num of I. Each num of I I'll check because each num of I will be a candidate. So each nums of I I'll check, for each element I'll check. And what I'll do, for each element I will apply the binary search from the next index until the last index, right? From I plus 1 until the end. So my low would be I plus 1, my high would be n minus 1, and I'll mark my flag as minus 1, indicating that currently I'll mark my flag as minus 1, indicating flag f is equal to minus 1, indicating that currently I haven't found the element, right? What I will do is a simple binary search approach. What I will do, while low is lesser equal to high, I'll simply calculate the mid. Mid is nothing but low plus high divided by 2. Now if the nums of I plus k, if the current mid element is equal to the element that I am looking for, that is for the current nums of I am looking for nums of I plus k. So if I get the nums of I plus k, in that case I'll mark my flag as 1, indicating that I have found the element that I wanted. So that's why I'll simply break from here, right? I'll simply break from this particular binary search. If I find the element, so I'll mark it as true that I have for the particular nums of I plus k is also existing. So flag means flag of 1 means that nums of I plus k is also existing, right? So that will mean that if nums of I is there, so nums of I is also existing. So that means one pair would exist, right? So that's why I'll mark my flag as 1 and I'll break. Apart from this, what I need to do, if the current mid element is lesser than nums of I plus k, the element that I am looking for is nums of I plus k. All of you can like the video. Please like the video, right? I have explained it in detail. So if the current mid element is lesser than the element that I am looking for, then I'll do what? Low is equal to mid plus 1. That is what I do. I will search in the right part of the array. I've told binary search a lot of times. Else what I'll do, if the current mid element is greater than the element that I am looking for, that is the element that I am looking for is nums of I plus k. If it's greater, then I'll mark my high as mid minus 1. Very simple. I'll search in the left part of the array. Now after this binary search is over, after this particular binary search is over from here till here, after this binary search is over, so if my flag is 1, so it will indicate, if my flag is 1, so flag is equal to 1 indicates that I have found that particular element. So for a particular nums of I, I'll be doing what? For a particular nums of I, I'll be inserting, right? For a particular nums of I, I'll be inserting its pair, that is nums of I plus k, right? So if the flag is 1, so that means for nums of I, I have found nums of I plus k. So I'll insert into the set, and this set will help me to take a check on every unique pair, right? Every unique pair of nums of I and nums of I plus k. And in the end, I'll just return the set dot size that will indicate whatever different number of elements I am having, right? So this is what I will do, right? This approach will take order of n log n time. Now another approach that I could do is, let me write the array once again for all of you so that we can discuss further. Let's say that if I had this same array, that is 3. Up till now, is the approach clear to everyone? You can give me a +1 or a clear in the chat. Now if I have 3 1 4 1 and if I have 5, if I have this particular array that I have, right, let's suppose that this is the array that I am having. Now what I can do is, I can get the concept of hashing as well. That is what I want is I want to check why to sort, why to do the sorting part, why to do the binary search part, right? I can use the concept of hashing. I can increase my space complexity by order of n. I can use a map to check for a particular nums of I. I can check that whether nums of I plus k is existing or not, right? Nums of I plus k is existing or not. That I can do using a map. And in this, the space complexity would increase, but I can check it in order of 1 time, right? We will insert the pair if it is not present in the set. Yes, even if the set pair is present, in that case it will not affect you, right? What is happening? I'm saying that if you have a nums of I, so you are doing what? If you have a particular nums of I, right? If suppose you are at the current element nums of I, so you are searching for what? You are searching for nums of I plus k, right? This is what you were searching for. So you were doing a binary search for this, right? But what I'm saying is, if you have a particular nums of I, so you want to search for nums of I plus k, you can do this in order of 1 time. How? By using the concept of a map. How you can do this? I'll let you know. So what you can do is, suppose that the current element is 3. Suppose that I'll first of all store all the elements into the map, right? I'll store all the elements into the map. So let's see what I'm storing in the map, right? So what I'm doing is, this is my map that I'm having. I'm storing the element 3 1 4 1 and 5, right? So these are the elements that I'm storing. Basically that means that I'm checking the frequency part. I'm updating the frequencies. So 1 is occurring 2 number of times, so that is why I'm doing it. Basically I want to let you know that I'm storing all the elements, right? So you can consider it like this, although it will not be stored like this, right? So I have the map. Samadhan, is this part clear to you? And what about others? Now what I'm doing is, if I am at the current element 3, if the current nums of I is 3, right? Suppose nums of I is equal to 3. If I am at this element, so what I am doing, I am checking whether nums of I plus k is existing or not. So what is the value of k? K value was here 2. So 3 plus k would be nothing but 3 plus 2, that is 5. So I'll check whether 5 is existing in the map or not. So is 5 existing in the map? Yes, it is existing. So at that moment I'll do answer plus plus or count plus plus, right? If a particular is existing, if for a particular nums of I plus k is existing, in that case I'll increment my answer, right? Because in that case I'll be having one unique pair, right? This is what I would be having. Now this is something that I have. That's perfect, right? And the map will help us to encounter the duplicate cases as well. Now the thing is, what I want to ask is, let us suppose that you are having some situation where k value is equal to 0. Suppose if k value is equal to 0, then in that case will you have a pair or not? Let's suppose this value was 2, right? So what I'm saying is, the map would look something like this, that is 2. So if my k value is 0, in that case, if suppose the element is 1, right? If suppose that the current element is 1, let us suppose that the current element is 1. If this current element is 1, so if the nums of I, that is the current element, is 1, then nums of I plus k, then nums of I plus k should be what? It should be 1 plus 0, that is 1 only. So in this case, what could happen? I'll see in my map if 1 is existing or not. So 1 is existing, I'll say yes, I'll do answer plus plus, right? But this will give me a wrong answer. Why it will give me a wrong answer? It will give me a wrong answer because 2 occurrences of 1 should be present, right? 1 is present only 1 number of time. 1 should be present 2 number of times, right? Okay, there should be more than 1 occurrence of 1. In that case only I will say, right? In this case, it's 1 is actually existing 1 time and still I am doing this, right? Which is not true. Which is not the case. Like it should be like this. If 1 was existing, one more 1 was existing. Like if this was the case, that is 1 1. If there were more than ones existing, so I'll check it specifically that if k value is equal to 0, then I'll check for this particular element nums of I. I will check that in the map if this particular nums of I is existing more than 1 time or not. Only then I'll increment my answer. Is this much part clear to everyone? Mahesh, Samadhan and others, please give me a +1 in the chat if up till now things are clear to all of you, and please like the video, right? What I'm saying is, if you were saying that using a bias search the complexity was getting increased and sorting part was also increasing the time complexity, so what I'm saying is you can search for the, if you have nums of I, then you can search for nums of I plus k in order of one time by using the concept of a map, right? By using the concept of a map. So if you have nums of I, so you can check for nums of I plus k. How? Just by increasing the space complexity order of n, pushing all the values in a map and then checking. Now there's one problem. One problem is that if the k value is 0 and you have just one occurrence of the element, right? If suppose that 4 is occurring one time only, right? 4 is occurring one time, and you will check in your map that whether so the repeat last one, which part you want me to repeat? If condition. Okay, what I'm saying is if you have this much part would be clear, right? If you have nums of I, then nums of I plus k should be present, right? But what I'm saying is if the element is occurring only one time, right? Suppose that the element is occurring only one time, that is 3 1 1 1, right? So if you are searching for 4, if nums of I is equal to 4 and my k value is 0, then the other value that I should have, that is nums of I plus k, it will also be equal to 4. And now you will go into your map and you will say that okay, nums of this particular value that I want is existing, 4 is existing, nums of I plus k is existing. But what I'm saying is if k value is 0, then in that case you are doing what? This same element you are considering, right, as a pair. But this should not be the case. Actually, if k value is 0, if the k value is 0, then you should check that whether this element nums of I is occurring more than once in the map or not. Only then you will increment your frequency, right? This 4 is actually existing one time. In that case you will not increment its frequency, right? Because it is existing only one time. 4 is not possible because it's not existing two times, it's existing only one time in this particular array, right? So that's why this will get you a wrong answer. So that's why this is one edge case, that if k value is 0, then in the map you need to check whether 4 is occurring or the particular nums of I is occurring more than once or not. If the frequency of map of 4, if the current element, that is if the frequency of map of nums of I is greater than 4, is greater than 1 or not, is greater than 1, it is occurring more than once or not. Is this much part clear to everyone? Shreya, Samadhan, Mahesh and everyone else, is this much part clear to everyone? Please give me a +1 in the chat if this much part is clear to everybody, right? I hope that it's clear to everyone. This is what I've said. Let me show you the code part for this particular problem. It would take order of one time only, right? I have provided the Java as well as the C++ code in the description of this video. What I'm saying is you take a map, unordered map in C++, right? You take a map of int comma int and you store all the values that are present in a map, right? So you map, like you put the frequency out. Now what you do, you have an answer is equal to 0. That is what the answer is doing. Like since we are iterating through all the keys of the map, so every pair will be counted only once, right? What I'm saying is you mark the answer as 0. If the k value is 0, then what is happening? If the k value is 0, then that particular element should be present here, right? That is nums of I is the is the first element and the corresponding pair is also nums of I. So in that case, nums of I should be present more than once. Only then you will increment your answer. Only then you will count as a pair. Now notice I am not iterating through the array. I am iterating through the keys, right? Keys one by one. What I am saying is otherwise, if the k value is not 0, so that means for a particular nums of I want nums of I plus k. So I'll search in my map. If nums of I plus k is existing, so that means that I will not go to the end of the map. If I find nums of I plus k, in that case also I will increment my answer, and in the end I'll simply return my answer. Now in this particular approach, since I'm using a map, so it will take nothing but order of n time overall and order of n space complexity, right, as I've told you. So this is the approach. In the description of this video I've provided the C++ as well as the Java code for both binary search and map, for Java as well as C++, so you can check it out. Also please like the video and give me a +1 in the chat if everything about the question is clear to you guys, right? You can give me a +1 in the chat, share it with your friends as well. I'm here for 60 seconds more. You can tell me if you have any doubt. What I said was, if you want to find the pairs, so the first approach for doing this particular problem was using the concept of binary search. You could have applied the concept of binary search. Second concept was, first approach was binary search, that is for the particular element. If you sort it and you have the element nums of I, if you want to find nums of I plus k, so for the index I plus 1 until the end of the array, you apply a binary search and you check every time and you put it into a set. Otherwise, you could do what? You could do mapping, or you could do concept of hashing. This would help you to find nums of I. For nums of I, you can simply very easily find nums of I plus k using the hashing of concept, right? This is what you can do, and it will take order of n time and order of 1 space. Binary search will take order of n log n time, because you are sorting as well as doing binary search, and it would take order of 1 space. This is how you can do it. If it's clear to everyone, you can like the video, you can hit the bell icon as well for this particular channel. You can subscribe the channel as well. Thanks a lot for watching, everyone. I'll see you soon in the next live. Till then, take care.